Most of them, or the two experiments that you need to look at, are about distance and penetration, and they're mostly talking about whether you can differentiate between alpha, beta and gamma. Can you tell which one's alpha, which one's beta and which one's gamma by how far they travel, or how they are, or what they are stopped by, the penetration part. So the first thing we've got to remember with any experiment is that we've got background radiation. Remember we talked about background radiation coming from rocks and cosmic rays and food and nuclear accidents and hospitals, all kinds of sources of background radiation. It's radiation that's around us all the time. So let's imagine that we've counted our background radiation and we've got 250 becquerels, or counts per minute. We've got to keep that in mind when we think about our experiment. Now let's think about the experiment two. Let's do number one, the experiment to differentiate between the three types of radiation in terms of how far they travel. So what do we need for this experiment? The first thing we need, of course, is our radioactive source. And the second thing we need is a Geiger-Müller tube. Geiger-Müller tube connected to a counter. So remember that it's got to be connected to a counter for you to be able to monitor how much radiation there is. So there's the counter in there. Remember that the radiation goes into the Geiger-Müller tube and causes a current that's picked up by the counter. So they're the main pieces of equipment you need for these experiments. The first one, the distance experiment, what you need to do is you need to measure the radiation close to the source. And when I mean close to the source, you need to measure it within a few millimetres of the source. And they're keen for that part there. Now remember we talked about alpha being heavy and relatively large and heavily ionising, and we know that it'll lose its kinetic energy very, very quickly and won't be able to be picked up as radioactivity. So we know that if we put our Geiger-Müller tube a few millimetres from the source and we lose our radioactivity, our count goes back to background, then we know we've got alpha radiation in that source. So let's imagine that at the source we had 1,000 counts. So if we had our Geiger-Müller tube right up against the source, we had 1,000 becquerels. If we moved it a few millimetres away from the source and it dropped back down to 250 becquerels, then we know that all of that 750 becquerels was caused by alpha. Heavily ionising, moved. Lots of ionisation close to the source, ran out of radioactivity very close. So that's alpha. If, however, we had beta radiation in there, we would still be counting radiation close to the source. So a few millimetres, we would still see a high radiation dose. We might lose a little bit, but mostly we'll be close to 1,000. If, however, we now move it back to a few centimetres from the source, probably about 7 centimetres is when most beta radiation is absorbed. So let's say if we move it to 7 centimetres, what would happen now is our count would fall to background levels. So now our 1,000 becquerels that we've got here is still pretty high, close to the source, a few millimetres from the source, but a few centimetres from the source, we're falling down to 250 becquerels. So that's telling us that the radiation in that source is beta. Remember that we have to have a high radiation reading several millimetres from the source in order to discount any alpha. If we had a radiation reading that was low, a few millimetres from the source, and then a further drop a few centimetres from the source, we may have alpha and beta in there. And then if we move the source further than a few centimetres away and we're still getting radiation, we know that after about 10 centimetres, what we will be picking up then, if we've still got a very high radiation dose, 1,000 becquerels, we may have less, we know that we've got gamma radiation. Okay. So to summarise for that question, make sure that you've got your source labelled in the thing. You'd be amazed at how many people forget the source. Make sure you've got your Geiger-Müller tube labelled and you've got it attached to a counter. Make sure that you clearly state that if radiation falls to background, so let's put falls to background is a really good term to use. If radiation falls to background a few millimetres from the source, then you know that it's alpha, and I'm just going to do the symbol for alpha. A few centimetres from the source, and we could say 7 centimetres from the source, we know that it's beta. And if it's beyond that, okay, let's say beyond 10 centimetres, then we know that we've got gamma. So if we've still got high levels beyond 10 centimetres, so these two are if it falls to background a few millimetres, we've got alpha. Falls to background a few centimetres, we've got beta. And if it's still high there, then we know that we've got some gamma in there. So that's the first experiment. These are the key marking points. So label the source, label the Geiger-Müller tube, label the counter in there, and make sure that you are clear about what you are saying there with those 3 marks. Most often it is just asking you to differentiate between alpha and beta. They may ask you to work out how much radiation is there, how much alpha or how much beta there might be there, and what you've got to do there is remember that you've got a background count of radiation. So for example, if you started off with 1,000 becquerels at your source, and a few millimetres away you moved to 690 becquerels, you could say there that 440 becquerels, because we've got to remember we've got to take off the background radiation, we can say 440 becquerels of that was alpha. Just remember that you may be asked for the amount of radiation there, and remember that the radiation that you measure or you take from your Geiger-Müller tube has to includes background radiation. So any reading that you get from your Geiger-Müller tube or on your counter from that Geiger-Müller tube, you have to subtract the value that you might be given for background radiation. So for example, here we might be measuring 690 becquerels at this point from the source. Remember, that is not 690. The difference between 690 and 1,000 is not what's been absorbed, because we've got 250 becquerels sitting there that is in the background. So 250 of that 690 is made up of background radiation. So the actual value here would be 440. Okay, to the next experiment, which is the penetration experiment, and that's kind of one that's more commonly either chosen because you might be given a question that says describe an experiment to differentiate between alpha, beta and gamma, and most people will choose the second one, the penetration experiment. So the setup is exactly the same as the last one. You need a Geiger, you need a source obviously, and you need a Geiger-Müller tube with a counter. So I'm going to just label it GM tube. This time I'm not going to write out Geiger-Müller again, attached to a counter. So there's our GM tube, and that's going to be attached to a counter. Here is our source. Now, when you write this experiment up or when you draw the diagram, these are the marking points for the diagram. If you think about it, if you are going to pick up alpha and beta, you need, for alpha, you need the Geiger-Müller tube to be close. So when you write about it, don't push this Geiger-Müller tube up in your diagram right up against the source, but make sure you write that you set the Geiger-Müller tube up, set the Geiger-Müller tube a few millimetres from the source. That's important. Otherwise, you'll have lost all your alpha before you start. Okay, what happens? All you need to do for this one is you need to put some different types of absorbers in there. And the three absorbers that they want you to know are paper, number one, and alpha is absorbed by paper. So if you've got your source and you've got paper in there, let's say we started off with 1,000 becquerels and we've put a piece of paper in there, and our Geiger counter now reads 250 becquerels. Let's write it in there so you can see. We know that this is background because we talked about that earlier. So all of that radiation that's come out of that source has been absorbed by the paper, and it's alpha that's absorbed by the paper. So the first one, if we get absorption by paper, it is alpha. So if we drop to background levels after paper, it is alpha. If we remove that paper and put some aluminium in there, so here I'm going to put aluminium. If now we drop to background levels, we know that is beta. And if you're interested in why that happens, think about the difference between the structure of paper and aluminium. The particles in the paper are further apart than the particles in the aluminium. So there are much more chance of the alpha losing all its energy as it moves through the paper than the beta. When the beta hits the aluminium, the particles are close enough together for the number of ionisations to use all the kinetic energy of the beta, if you're interested in why. But the important thing here is that alpha is stopped by paper, beta is stopped by aluminium, and the last one, lead, if we put a lead absorber in there, that's what's needed to stop gamma, and it's often thick lead. So here we've got our thick lead, and that is going to stop gamma. So, run that here. So let's go back and go through the marking points for this question. So make sure you've got your source, make sure you've got your absorber labelled. So let's write that, absorber. Make sure you've got your absorber labelled. Make sure that it is close to the source, so a few millimetres from the source. So number one, make sure you've got your source, make sure you've got your absorber, make sure you've got your GM tube. Make sure you have been careful to say it is only a few millimetres from the source. Then what you need to say is that alpha is absorbed by paper, aluminium absorbs beta, and you need thick lead to absorb gamma. They're the key marking points. The other point to make is you are going to, how do you know that it is absorbed? You need to say that the count falls to background level afterwards. So I'll just write that on the side of there just in case you want to stop this video and get that in your notes. So those are the marking points that you need for this experiment, and obviously how they award those marking points depends on the exam and the time of and how they've put the marks together. So it might only be 3 marks, it might only be 3 marks here, it might be 3 marks for this. These 2 extra marks, saying the millimetres from the source and the background, are always worth saying anyway in any of these in any of these type of experiments. So those are the experiments for radioactivity.